Yeah, go ahead. Okay, welcome to the AMSOIL Technical Information Series. In this segment, we will be discussing many of the performance classifications relating to engine oil. If you've ever had a question as to how to determine the general performance of an oil or whether or not it's suitable for your application, hopefully this segment will help. In starting, we should note that there are about three main types of engine oil out there. First one is for spark ignition engines or gasoline type engines. A second one, compression engines, which would be our diesel. And then another group that really includes a wide variety of different sub-applications. Two-cycle engines like we see in whether it be a snowmobile or a chainsaw or weed trimmer, that type of thing. Or gaseous fuel engines that may be running methane or waste gases from a landfill, that type of thing. You wonder why different main groups? Well, all of these certainly have to address the main functions or main requirements of a lubricant. But each one has a little different set of needs and desires. And in order to properly meet those and provide the best possible performance over the longest period of time, we're going to have to adjust not only the chemistry, but in many cases, other characteristics of the oil. Engine specifications. It's certainly nice to have specifications out there for different applications because they do establish at least a minimal quality level for an oil, and that's done to help ensure customer satisfaction, performance of the equipment, and certainly longevity. It also eases applications and recommendations for what type of product to be used in a certain piece of equipment, especially so on the level of the consumer itself on there. We talk about specifications, we talk about approvals. Certainly specifications are not the same as an approval or a certification. In all situations, however, specific requirements do have to be met. Now, whether or not they require a review by the equipment manufacturer or it may be a self-certification is going to be depending on the situation. A key point regarding approvals and certifications is they really don't differentiate performance beyond that of meeting a minimum set of requirements. The big takeaway here is you can have two oils meeting the same supposedly performance level, however they function, they last, they operate totally different in an application. Specifications can be limited as to the performance that is available. There may be a limit on how much chemistry can be used or the type of chemistry. All of these can have a major effect on how that oil is going to perform and the length of period of time it is going to function properly on it. When we take a look at the folks that put together a lot of these performance classifications and specifications, most notable, especially in North America, are the Petroleum Institute, API, International Lubricant Standardization Acceptance Committee, that's ILSAC group. They deal more specifically with automotive or car type applications. ASEA, the folks over in Europe, they get involved certainly with the equipment that's manufactured over there. Society of Automotive Engineers, they're usually involved in this. And original equipment manufacturers can have their own specification and certification programs outside what all of these other groups are doing. When we take a look at the API and how they work, basically they work in conjunction with many of the other groups that I just mentioned out there. The first thing is somebody's going to have to define a need. What do you need? What's the situation? What's the issue? Somebody's going to have to define that. And it's usually the equipment manufacturer or people like the Society of Automotive Engineers or JAMA. That's the Japanese Automotive Manufacturing Association. Those folks are going to decide or define what's required, what's needed. Then they're going to go someplace else. They may come down and they may talk to people, let's say like from the ASTM, Society of Tribologists and Lubrication Engineers, or ASTM, and say, hey, is there something out there that can help me define this problem and then give me some handle as to whether or not changes that I make, improve the situation or not? What do you have on it? Well, once they get all of that, they get some test protocol, test methodology set up, and they run everything. Now they have to have some way, some consensus as to how they're going to present this, especially to the consumer, some language, some protocol. How are we going to do it? Everyone that passes this new requirement gets a star, or a big letter A on the can. How are they going to do it? What's the protocol? What's the language that they're going to use? So it kind of goes round and round. They all work together on it. The only real difference in here is sometimes, again, you can have specific performance categories or levels, specifications set up by the original equipment manufacturer. They're going to kind of all do all of that themselves, all right? And they may do it for a specific reason, and we'll talk about that in a moment or two on here. Getting back to the API, like I said, they're going to work with the other groups, and they're going to define the minimum lubrication requirements for physical properties and performance that the oil must have. And this is really the key performance standard that's used in North America. It's also widely used around the world, but there are other standards, and we'll talk about those in a minute, that are perhaps a little more popular, used a little more in other areas within the world itself. But the API performance categories are probably the most widely recognized worldwide. They basically have two main classifications or categories. First one, they refer to that as the S category, that deals specifically with gasoline-fueled engines. Not diesel or any methane or anything like that, solely gasoline-fueled engines. They have two major concerns: wear protection and fuel economy. Now, yes, they have to deal and review with all the basic functions that lubricants have to have. But the two additional main concerns that they have are what we talked about, wear protection and fuel economy. Okay? On the other side, the other half, the C category, deals with compression ignition engines, basically diesel engines. No gas, nothing else, diesel engines. Okay? Now, yes, again, they're dealing with all the basic functions that oils have to perform, but their key areas of concern are detergent dispersancy level of the oil, cleanliness. Cleanliness is an issue. You got to remember, when you burn diesel, soot is a byproduct. And soot can be a real dirty, nasty thing. It has to be handled correctly. It's not a situation when we deal with gasoline, soot's not generated, not to the same extent. So detergent dispersancy is going to be an issue. Elevated total base number, its ability to neutralize acidic solutions or materials is a concern, and thermal stability. So we're going to have, because of the importance that these categories put on different properties, characteristics, and concern, we're going to wind up with products that have a lot of similarities to them, but a lot of chemical differences within. Okay, what do we have for the API standard for the S category, the S classification for gasoline engine oils? All of the standards start off with a common letter. For the gasoline engines, it's going to start off with an S. Okay? The first standard that they ever came out with a long, long time ago was classified SA, beginning of the alphabet. That was nothing more than really an engine oil that contained nothing more than rust and oxidation inhibitors. Pretty much a straight oil, which worked fine for a while, but of course, as demands placed on the oil change, the oils have to change accordingly. As the demands changed and as they came up with new classifications, they started moving up the alphabet. The most current API standard for gasoline engines is SN. And it takes into consideration all of the situations, all the issues that the older standards did, but now some additional concerns. Compatibility with ethanol, for example, deposit formation, thermal stability in turbochargers, increased operating temperatures, fuel economy. They're always pushing better fuel economy. And as the demands and requirements increase, they have to go to different standards to ensure that quality of product is being used on it. One of the things to keep in mind, these standards tend to be backward compatible. So if you have an older vehicle that, hey, let's say calls for an API SJ product, all right? And you may not even be able to find that type of product on the market anymore. You can, without any concern, utilize an SL or an SM or an SN oil in there. Backwards compatible. So a little safety there. When we take a look at what the API requires as far as performance, there's page after page of tests, whether they be compatibility with elastomers, the gaskets and seals, whether it be volatility, how much life fractions are in the oil, whether it be cleanliness issues or wear issues. There's a number of things that have to be reviewed, and there are minimum performance standards that are required in order to classify a product in a particular grade. Virtually all of them have engine tests. For SN, for example, I have just 7 of the engine tests that the oils have to be subjected to in order to indicate that yes, indeed, they meet at least the minimum requirements for an API SN service or performance category. A lot of work involved in there, a lot of time, a lot of money. When we looked at the diesel side of it, the C category on there, basically it's the same situation. Instead of starting with the letter S for the performance category or standard itself, we use a C. Designates the category that it's in there. First oil was CA. Okay, again, nothing much than oil with a little rust and oxidation inhibitor on it on best. As demands changed, they've had to have oils that perform at a higher level. We go up and up. The most current one is that CK4, designed to be used in the newer high-speed diesel engines, especially those that have the most current emission standards on it. Things like exhaust particle traps and catalytic converters and so on and so forth. There is one little change here. Now we see on the top here an FA4. What the heck is that? I thought C was the indication of the diesel category. Well, that FA is a little diversion. Basically, they're looking at the same type of concerns, the same type of issues, directed towards the same type of applications. However, the FA4 deals with oils that have a very low dynamic viscosity to it. And that's something new that they're looking at. Why are they doing this? Well, a big part of it is fuel economy. Lighter viscosity oils, generally more fuel economy, but then we have to look at durability, so more testing. Backwards compatibility, for the most part, yes indeed, it exists here. There are a couple of exceptions in there, but we're not going to really go into them in too much detail on it. Okay, one of the things that you can run into is oils that have both a S performance category listed on it and a C. Well, that would certainly indicate it can be used in both applications. Many cases that is true. There are a lot of all fleet or mixed fleet oils out there that are used in applications where a company or whatever has both gasoline engines and diesel engines. And yes, in order to do that, the chemistry would have to be adjusted to contain those types of additives and materials that allow them to function in both applications. For the most part, however, most of the oils out there are only designed to run and continue to provide maximum performance in either one or the other. Sometimes too, what we'll see, let's say like in a gasoline engines, and this is something that has changed a little bit, but what we saw a few years ago, when they introduced turbocharging, or the popularity of turbocharging gasoline engines became more and more popular for the average consumer on there, high temperature became an issue. Well, just so happens on the diesel side, they've been using turbos for years. High temperatures have been an issue for years. They've already got a test to see whether or not that oil can function in that type of environment. So many of the new gasoline engine oils would also include this diesel spec on it, because they had to run that test to see how it was going to function in the gasoline turbines until they were able to come up with additional gasoline engine tests to review that as well. So that's why you see some of that mixture on there. But even though both ratings are on there, that doesn't necessarily mean that it's really the best possible product for both applications. However, we can reduce some of the compromise, and there are specific oils out there that are directed towards mixed fleet applications. Okay, API, how do you know the oil's been reviewed or compared to their standards? They'll usually have a couple of things on it. They may have a certification mark on it, as we see on the left-hand side here, basically meaning the results have been reviewed by them and it does meet their requirements. Or they could have the service donut that you see on the left there. That gives you really a whole bunch of information. In the center there, it tells you the oil weight, grade, or viscosity that's required, or that that oil is on there. You want to match that up with your owner's manual on the car on there. Up towards the top, the API service classification on there. In this case, it's an SM, which means it's an older, because I just told you a minute ago the latest one is SN. So this would be a little older chemistry. Maybe not quite as good for all applications on there. Down on the bottom, we have energy conserving. A lot of that has to do with what we refer to as ILSAC, which looks, they're very, very concerned about providing additional fuel economy, and if it's energy conserving, it suggests that this particular oil will provide you a little better economy than oils that don't meet that requirement on there. And when we're talking a little bit, we're talking a real little bit. Don't expect 5-10% or anything like that. We're looking at 2% or less. So nothing huge, but it's there. ILSAC, this is the group that I just mentioned. They're the ones that really look at the fuel economy. ILSAC does similar work to API. They actually came about because EPI was a little slow on the jump to get some new specs out. And the equipment manufacturers were basically saying, hey guys, we like what you do, you know, we're behind you 100%, but we've got to get some new specifications out there. You're not keeping up with the technology. And ILSAC got to the point where they decided to come up with their own specifications. They only deal with gasoline engines, not diesel. So never look for an ILSAC specification on a diesel oil, because that's beyond their scope on there. They also only deal with lighter viscosity oils. Your 0W20s, 5W30s, that. You'll never see a 1040 with an ILSAC, or saying that it meets an ILSAC spec, or a 20W50. Okay, it doesn't pertain to them. It's not what they're dealing with on it. Anyway, it's a group of automotive applications that have developed their own test methodology for reviewing concerns that they've had that API just hasn't had time to address. So that's out there. What is it? Well, basically, it starts off with GF, gasoline fueled. I guess that's what that stands for. I don't know. It's somebody's nickname. Number one was the first spec, basically looking only specifically at fuel economy. Again, as you go up in the numbers on there, they're looking at more and more fuel economy on there, but they're also looking at emission life expectancies and issues on there. They're also looking for oil life expectancy, a number of things. GF5 is the latest, but we plan on, or we anticipate seeing a new GF6 being introduced sometime in 2018. And that's going to be divided up too in the normal grade oils, the 0W20s, 5W30s, that type of thing that we talked about before, but also to take into consideration the new SAE 16 grade, even lighter oils. That's out there. ASEA is kind of Europe's version of API, with a little more to it. They have their own performance categories as well. A little more diverse than API. They have, yes, categories divided up between gasoline and diesel applications, but they also have categories that look at other things as well. Emission control systems on newer one, heavy duty diesels versus light duty diesels. We have an example here. A's are for gasoline engines, B, light duty diesel, C, that's when we get in the emission control type situations to a greater extent, and E, that's your really heavy duty diesel situation. Within each category, they have subcategories as well. The subcategories will define performance level even more. It will talk about, in some cases, engine oil longevity. Some of these oils that are specific done when you get into the heavy duty diesels, for example, E7s, E9s, tend to deal more specifically with extended life service oils for heavy duty application. It really divides it up much more specifically than the API does on there. Again, you can have multiple ratings on there, both gasoline and diesel. So in many cases, they can be used in mixed fleet type applications. For the most part, the higher the number, the higher level of performance. Okay, doesn't carry through 100%, but it's a good generality on there. I'm not going to go through each one of them. This kind of defines them in more details, what each spec was really concentrating on, and a little bit how it differs from the one below on there. But the ABs are A's for gasoline. B is basically for your light duty situations on there. Okay, catalytic converter oils, higher emission oils. Again, the higher the number on there, you're going to get into a more technically sophisticated type of product on there. E's again for a heavy duty. Again, we have the same scenario there. It's not important that you really have a firm understanding of the individual numbers and what they represent on there, just to know there's different categories out there. Because we'll get into a couple of minutes what you're going to do with that anyway on there. OEMs, we said they can have their own type of specifications out there. Virtually all of them do. General Motors have the Dexos 1 and Dexos 2 for gasoline and diesel application. Ford Motor Company has had material specs and everything for engine oils for years and years and years. They continue to do so. Again, a lot of times they're doing this to get a jump ahead of the API. They're putting out new engine technology on there. It's brand new to the industry. API hasn't had a chance to work with the other departments to come up with a new service classification. OEMs are saying, okay, I understand it. In the meantime, we're coming out with our own specification or standard. And that's what they are. Mercedes, Porsche, everybody's got it. We see the same thing in, let's say, like the heavy-duty truck industry. Again, here's some different classifications on here. And a lot of these correlate quite a bit with the API service classification. Mack Truck, for example, on the EON Premium Plus O3, pretty much the same thing as an API CI4, a little more stringent on some of the requirements on there. Cummins, we can see the same thing. We even got some listed there for natural gas applications. Caterpillar, same Detroit Diesel on it. Okay, we got a little idea on the performance classifications. We know that, hey, they're not going to give us specific data. You know, what were the wear results? How dirty was it? They're not going to give you that data. What they're going to do is they're going to give you some type of performance classification, that engine requires that you're going to try to fit a product into. So what are we going to look for initially? Viscosity, the thickness of the oil. Why do we do that? It's the most important characteristic of the oil, regardless, viscosity is. Okay. Second, we're going to look for any performance classification that the manufacturer recommends. Also, too, we're going to look and see if there's any special needs. For example, I talked to you about that one Ford spec that just came out, happened to be related to diesel applications. API really didn't have a specification that Ford believed properly dealt with some of their newer issues. So we basically may have an API service classification, but there may be something else that the equipment manufacturer is telling us to be aware of and make sure your oil is formulated to meet that. Okay, where do we find information as to what's the right oil for our application? All of those are the same, right? Well, we know they're not. All applications are the same. It's a car engine, it's a truck engine. They're all the same. Any oil should work in it. Well, we know that yes, they could all work. Water would work in all of them. The question is, how well will it work and for how long? All right. We can look at the piece of equipment itself. Most cars and trucks have an oil filler cap on there. A lot of times there'll be information on there as to what oil to use. In this case, we have a viscosity listed on there. Well, that's one of the questions that we have. Doesn't say anything about performance, but at least we can get viscosity right. It may be another piece of equipment. It could be a differential or a transmission in a mobile application or a piece of industrial equipment. There are these equipment tags on there. In this case, it says use a motor oil. I guess any motor oil will work for what they're saying there. And it gives you a viscosity grade on there. In this case, it gives you a temperature range too. The temperature range is there because we know the viscosity or the thickness of any oil will vary depending on ambient temperature. So we may have to adjust accordingly. So we may get information there. One of the key things, and one of the things people don't know, is they don't read the owner's manual of new equipment. I know it's boring reading. I know there's not a lot of pictures in there and that type of thing. But folks, you really should look at it. And I hate to say it, I try to always read the owner's manual of every new piece of equipment that comes into the household. I don't do it. Just so happens, not more than a couple of months ago, I was going through the owner's manual of my wife's vehicle, found 4 or 5 things on there that the car will do that we had no idea it would. So hey, when you get a spare few minutes, it's a good idea to go to the equipment manual. What do they usually do? They'll usually define specifically what type of oil goes in what piece of equipment, what component on there. Is it a motor oil? Is it a hydraulic fluid? Is it a gear lubricant? If it's a gear lubricant, is it an extreme pressure product or just a light grade type oil? It really will define it for you, what type of oil. List viscosity. Here again, we see a whole list of viscosities, and as we know, temperature can affect viscosity. At what temperature ranges those viscosities or those thickness or grades of oil should be used on there. Really clears it out for you, you know. Another thing it does, which is really, really helpful if you're kind of a do-it-yourselfer, like to change fluids on vehicles and that, capacities. You know, I got to change the transfer case in my new 4x4 truck. Do I buy a gallon? Do I buy a pint? I don't know. This will at least give you some guidelines. But owner's manuals, great places to get the type of information that you need. Okay, on there. Here's another version on here. This happens to be a Chrysler product in here. It says use a 5W20 on it. Okay, that's okay, but it doesn't list any API service classification. What do I go off of? What it does list in there is a Chrysler material standard or Chrysler specification. So what we're going to want to do is we're going to want to match any oil that we use or look at any oil that we use to ensure that it says that that product was formulated to meet that minimum quality specification. Okay, so we got some idea, you know, as to what the equipment needs. Now we need to determine the oil that we want to buy if it can meet those requirements. It's relatively pretty easy. Just look at the container for starters. The front of it will usually give you two pieces of info or one key piece of information, and that's viscosity or oil thickness, grade. You know, the manual says use a 5W20. Ah, no, this is a SAE 5W20 oil. So I got the viscosity side down. Okay, we're looking good there. You may have to go a little deeper on the back of the package itself. Start looking around. If we look at the left-hand side here, we see some of the performance categories that this product was developed to meet. Well, it's got an API, a service classification on there, SM or SN. Those are the latest ones. So, as long as the owner's manual doesn't recommend anything higher than that, which there isn't anything right now, we should be in good shape. Also lists ILSAC information, some ASEA information, and it lists some specific OEM or the original equipment manufacturer specifications. And look down at the bottom there. There's that Chrysler spec, that MC6395N. Oh, well, okay. Owner's manual says that's what I need. Looking from a performance standpoint, we should be okay here too. You can get also information if it's got an API service donut on it. It will list the API performance standard on there, viscosity, and the ILSAC, or that reserve energy efficiency conserving a part on the lower portion of the donut itself. So, hey, the product container should tell you all of that. What happens if you don't have the product? See if you can get a hold of a data sheet, because the data sheet will usually give you the same type of information. Usually look at the application, you know, and see if you have the proper, the oil of the proper viscosity meets those specifications on there too. Also too, another thing about data sheets, they define the intended application. Now we talked about different engine oil types. We talked about gasoline engines versus diesel engines versus other type of engines. The oil should be application specific. They should list someplace, indicate, is this for a gasoline fueled car? Or is it for a lawnmower? What is it? Because to get the best possible performance, you are going to want to get an oil that has been formulated for a specific application and not a general application. We all get back to the thing, how well will it work and how long will it work? If it's application specific, you're more likely to get the highest level of performance for the longest period of time. Data sheets will tell you that. Usually packaging will tell you that as well. Okay, getting into another thing, I just thought I would throw this up here. these SAE grades, this viscosity grade, 10W30, what does all that stuff mean? The large number in the 10W30 up there, the large number on the right, basically is giving you information as to the thickness of the oil at high temperature, operating temperature. Is it going to be able to carry the loads, protect the unit at operating temperature for a long period of time, okay? The number on the left, at 10W in this case, is going to give you information as to what they refer to as dynamic viscosity, or things like pumpability, flowability, that type of thing. Is it going to have issues functioning at cold temperatures? Is it going to provide better fuel economy with the lower number? That type of thing. They utilize ASTM test methods to determine the viscosity or thickness of oils at various temperatures. That data is then referred to a chart that has been put together by the SAE, the J300, and depending on where it falls within the ranges will be the indicated SAE grade. For example, if we look all the way down at the bottom of the chart there, right above where it says kinematic, we see a range of 21.9 to less than 26.1. If it falls within that grade at 100 degrees Celsius, it's considered an SAE 60, and we can go down the line in there. This allows you, without having to deal with the hardcore data, to help ensure that you're going to get a product that has the load carrying ability, it has the viscosity, the thickness that is required for your particular engine, particular application. I just thought I'd throw this in. There is a service classification for gear lubes out there. That's basically mainly for mobile applications. Basically, we're talking about transmissions, manual transmissions, differentials, transfer cases, that type of thing. It's put together by the API, GL classification, standing for gear lube. Number one is basically the most mildest of conditions. And in most cases, applications calling for a GL1 can use nothing more than a conventional motor oil to meet it. As the demands increase, the chemistry has to change. We jump right up to GL4. GL2, GL3 has been discontinued. GL5 is probably the most severe out there, and that's for hypoid type applications, a lot of sliding pressures and so on and so forth. Basically, it's when you run into a high demand for what they refer to as extreme pressure fluids. Won't define those right now. MT1, that's a little different. It's more of a compatibility type a standard for transmissions, especially those with non-synchronization or non-synchronized type application. That's been out there too, so they have that out there. And they have a different grading system. They use similar type numbers, but the ranges and everything and the actual numbers are a little different. You can't compare the two. Just kind of threw that out there for extra information. Okay, really in kind of review consideration here, what are the main requirements that you're going to be looking for when you're looking for an oil? Number one, viscosity, the oil thickness, the grade on there. Performance classification, you want to ensure that that's met on there. Application specific. Application and specific. You don't want to use, for example, an automotive engine oil in a motorcycle application. You don't. They have different needs, different requirements. Their chemistry is going to be different. To get the best performance for the longest period of time, you want to get something that has been formulated for a specific application. Other needs that may be called for by the equipment manufacturers. And you certainly want to take a look when making your decision about any additional benefits or advantages one product may provide over another. Fuel economy would be one thing. Longevity, if an oil lasts significantly longer, there is a benefit to buy that product over another. Okay, on that particular point, we'll end this segment, and thank you for your time.